we're going to learn how to find the coordinates of stationary points and determine whether those stationary points are a maximum or a minimum. We're then going to use that information to sketch the curve. So let's consider again the gradients of the parts of this curve. So between x equals a and x equals b, the gradient is positive. At the point B, the gradient is 0. Between B and C, we have a negative gradient. At the point C, the gradient is 0. And between C and D, we have a positive gradient. So at the points B and C, the curve is 0 because the tangent at these points is horizontal. We therefore call these points B and C stationary points because the function isn't increasing or decreasing at this point, but it is staying stationary. So at the point B, if we look at what we call the gradient profile, we can see that the gradient goes from positive, just to the left of B, to 0 at B, and then to negative just to the right of B. And this creates a maximum point. So a maximum point looks like that. At C, if we look at the gradient profile, the gradient to the left of C is negative, then at C it's 0, and to the right of C it's positive. And this gradient profile creates a minimum point, which looks like that. So a maximum point, we have the gradient going from positive to 0 to negative, and at the minimum point we have the gradient going from negative to 0 to positive. So in order to find the position of stationary points, first of all we find the x-coordinate of the stationary point by finding the x-coordinate where the gradient is 0. So we would find dy by dx for the equation of the curve, put it equal to 0 and solve that equation to find the x-coordinate. And then we would find if the stationary point is a maximum or a minimum by testing the gradient either side. So as we've just seen, for a maximum point, our gradient will go from positive to 0 to negative, and for a minimum point, our gradient will go from negative to 0 to positive. So let's go through this example here. So part A wants us to find the coordinates of the stationary point. So the first thing we have to do is define the gradient function, dy by dx, and then we write at a stationary point, and we can write SP for short for stationary point. At a stationary point, we know the gradient is 0. So at a stationary point, dy by dx equals 0. So it's important that we write this in our workings. So we put our gradient function, 3x squared minus 12 equal to 0, and then we solve that quadratic. So if we factorise, we could take out a 3, and we would have x squared minus 4 equals 0. We could then divide through by 3, so we get x squared minus 4 equals 0. We've got a choice here. We can either take the 4 on the other side by adding 4 to each side and square root, or we could factorise using difference of two squares. If we just take the 4 on the other side and then square root, we mustn't forget that we get a positive and negative square root, so we get x is plus or minus 2, and we remember it's a quadratic equation, so we are expecting two x values. So that's given us the x coordinate of the stationary point, but it says it wants the coordinates, so we need to find the y coordinates. So we're going to find the y coordinates by subbing x equals plus or minus 2 into the original equation of the curve. 3x cubed minus 12x plus 3. So when x equals 2, y is going to equal so that gives us y is minus 13. So we have our first stationary point at 2 minus 13 when x equals minus 2, we substitute in minus 2. And if we work that out, we would get y is 19. So our second stationary point is at minus 2, 19. So that tells us our coordinates of our stationary points, but it doesn't tell us if they are maximum or minimums. That's part A finished. Now we need to classify the stationary points. So what that means is determine their nature, find out if they're a maximum or a minimum. So we're going to need to test the gradient either side of the x coordinates of the stationary point. And it can be quite nice to set up a table to do this. So we can have our x coordinate here, and then we're going to find the gradient at each of these x coordinates. So what we're testing is minus 2 and 2. So if I've got x is minus 2 and x is 2, and I know the gradient there is 0, what I need to do is test the gradient either side to the left and right. So if we choose minus 3 to the left of minus 2, and then in the middle we could pick 0, and then to the right of the 2 we could pick the 3. So if we wanted to create a table here, where the top row is the x coordinate and the bottom row is the gradient at that x coordinate. So to find the gradient at the x coordinate, remember we need to substitute into the gradient function. So let's just remind ourselves the gradient function is 3x squared minus 12. So when x is minus 3, if we substitute in minus 3, all we really are trying to work out here is the gradient positive or negative. And I can see here that I'm going to get 3 times 9 minus 12. So that's going to be a positive gradient. When x is 0, if we substitute in 0, the gradient is going to be minus 12. So there I get a negative gradient. And when x is 3, if we substitute in 3, again we can see we're going to get a positive gradient. So if we look at those gradient profiles, when x equals minus 2, the gradient's going from positive to 0 to negative, positive to 0 to negative. So that tells me that the point minus 2, 19 is a maximum point. And then here when x equals 2, I can see the gradient goes from negative to 0 to positive, negative to 0 to positive, and that tells me that 2 minus 13 is a minimum point. So all that remains to do now is to have a look at part C and sketch the curve, and it wants the stationary points, the coordinates of the stationary points marked on, and where the curve intersects with the y-axis. So let's go down then and have a go at sketching this curve. So just write out the equation of the curve again. So the equation of the curve was y equals x cubed minus 12x plus 3. So let's draw some axes. And I can see that I've got a maximum point at x equals minus 2, so to the left of the y-axis, and a minimum point at x equals 2, so that's to the right. I've got a cubic curve, so I know its general shape, and I know the y-intercept is going to be plus 3. So I'm going to draw in the curve with its general shape, and then I'm going to mark on the coordinates. So maximum minus 2, 19. Minimum 2 minus 13, my y-intercept there is 3. Just make sure you read the question carefully when you're sketching curves to see if it wants you to mark on the x-intercepts as well. This one doesn't. Sometimes if you're sketching a quadratic it will want you to do that though. So that was quite, if we just go back to our table, we can see that's quite a long way of determining if we've got a maximum or minimum point. There is a quicker way. So let's just have a look at what the quicker way is. So if we have a look at this red curve here, if this is my original function, if I found the first derivative dy by dx and I plotted that, so I plotted the gradient function, so that's this curve here, that should have a minimum point joining there. What we can see is at the maximum and at the minimum point that the gradient function is 0. So this is just sort of slipped out of alignment very slightly, but at the maximum point we should see the gradient is 0 here going through the x-axis, and at the minimum point the gradient is 0 here going through the x-axis. What we want to look at is what the second derivative looks like. So if we found the second derivative of our original function and we plotted that on a graph, what we would see is at the maximum point, so remember this green line was at the maximum point, my second derivative is negative because it's below the x-axis. But the purple line came from the minimum point, and at a minimum point the second derivative is positive because it's above the x-axis, and we can use that to determine the nature of the stationary points. So this is called the second derivative test for classifying stationary points. So we know a stationary point dy by dx is 0. If we then find d2y by dx squared at that x coordinate and it's negative, that tells us it's a maximum point. If we find d2y by dx squared and it's a positive, that tells us that the stationary point is minimum.